Hey guys, it's Vince. Today in this video, we're going to take a look at some more spindles. When I say spindles, I'm talking about spindle installations. Now, many of you already realize that really this topic has been beaten to death like a dead horse. Unfortunately, what we're seeing is an influx in the industry of more new end users, and with that, we're seeing them naturally grab their camera and decide to put content on YouTube. And when you combine those two things with a novice and no research being done, and then them naturally hitting the camera and uploading as fast as possible to social media for content, these are the type of videos that we have. Let's jump right in and see where we're going.
I'd say decent packaging. I'd say kind of a fail on not having a power cord for the controller. Well, I managed to find a power cord in my stash.
All right, guys, so let's think about what's going on here. Apparently, the content creator slash end user purchased this ready-made package with a VFD and a spindle. We're seeing a lot of these trickle in overseas now. A lot of them are coming in from the States as well. We see packages being made. And he feels that his package should have came bundled with the proper power cable for his VFD. He called it his controller. Could be an honest mistake. It's the VFD. The issue with this that everyone out there should understand is no VFD technically comes with any cables. So if you're an end user who is just beginning in this genre and you're a novice, you need to understand you will have to provide the proper double shielded cables and understand how to properly ground these cables in order to make them effective at mitigating the EMI that's present from the VFD and spindle. Fact. That being said, let's see if he got lucky. Many guys aren't who buy these packages because many details are overlooked. And the main reason that you don't see that many is because there are so many details, but maybe this guy got lucky. Let's see where this goes.
Stuff. Here's a wiring diagram for
we got a wiring diagram.
Wiring up to the motor and wiring up to the power source. So I'm going to go ahead and do those things and then just test to make sure the motor runs.
So he just got his spindle package unboxed, and immediately the novice end user says, let me plug it in and see if this thing works. What I feel is best practice is you first go over all of the cables to make sure they're assembled correctly, guys. And when I say correctly, I mean that you should be going over all of the solder leads, make sure they're actually soldered if they're using ring connectors as they should be, and also make sure that the cables are assembled properly where grounds are to be allocated so that you mitigate EMI. If these cables, both of them, the one powering the VFD and also powering the spindle, are made in an inferior manner, you yourself are at risk along with anyone else in your shop, your house, and whatever else it may be. These are areas of concern that I've brought up before. And again, I reiterate it in all my videos because when I see guys so excited to just plug the unit in and see where it goes, they tend to forget everything is running through these cables. And in the event that there is a problem, meaning with the assembly of these cables, this could be catastrophic. We need to pay attention to this. Let's see how he makes out. Okay, we can see here where the cable's exterior casing has the leads coming through it. And we can also see that there is no insulation over this. This is horrible, of course, but in this particular instance, for examination purpose, it's good. Now we can see that there is no shield drain coming through that exterior casing, which means this cable is not properly grounded to mitigate EMI. So even if it's shielded, as it should be double shielded, once again with mylar foil and tin braided copper to properly function, it does not have a shield or shield drain allocated to the ground lead for the VFD, and which means this cable is functioning just like a regular cable. Now, once again, I'm pointing out that this is a novice end user, and the reason I'm stating that is he would have been aware of this, and that should have immediately been a red flag. If he paid attention to the listing carefully, and when I say carefully, I've already pointed out previously in that video footage, where that casing has that tinned copper coming through it. And of course, the shield drain is not present. But if you look carefully also in the listing, you'll find on Amazon, it does not state shielded or double shielded cable at all. So these are areas of detail that they try to brush over the eyes of novice end users. And once again, this content creator got burned.
Well, in a completely bonehead move, I cut off the wrong end of the cable, so the plug-in part, I guess I would have to have it plugged straight into the wall or something. I don't know. Anyway.
All right, so we saw that the content creator actually removed the wrong end of the VFD's power cable. But even before that, it's apparent he selected the wrong type of power cable. All of the cables used on your spindle assembly, the VFD itself's power cable and the VFD's power cable going to your spindle, must be double shielded. We do not want to have radiated EMI, and therefore that's why we use double shielded cables. Now, it's interesting. We see a lot of content creators, make light of a mistake that they make. And, they try to make the video entertaining, they're self-deprecating, whatever it may be. That's cool, but I think it would be more beneficial also to go into detail of where I went wrong. And when I say go into detail, show why this cable should be used in the format it is, meaning which end he should have worked with. Again, you're modifying a power cable, which would make no sense if he did more research on the topic at hand. Once again, defining he's a novice. Once again, defining should he be making a video on a topic that he truly does not understand. Because we know that there are going to be end users watching this video in his audience or that come up randomly when they search Google, and he could inadvertently, and why I say inadvertently is I'm not saying he's deliberately going out there to hurt anybody. I don't feel any of these content creators are doing that. I hope they're not doing that. But overall, if you're providing misinformation, you're not doing these people any justice. You should just stay away from topics you don't know.
Managed to find another cord. So let's cut off the proper end, which is this one.
So the content creator is about to butcher another general power cable, and in this case, it's an IEC power cord. Once again, he's a novice. The reason I'm saying that is not because I'm just generalizing it. We are seeing he's a novice. He does not understand that a VFD and a spindle cable, when I say that, I mean a VFD power cable and a VFD spindle cable, meaning to power the spindle, are required to be double shielded to mitigate EMI so that once again we don't radiate EMI and once again disrupt any of the critical step and direction signals for his robot. Now, there's always some people out there, just a few, that claim to watch the video, which I feel they really don't, or if they watch the video, they have a problem with comprehension in that they feel I'm bashing the content creator, I'm coming down on them. The bottom line is this, and I'm going to ask these people a question, and I want to see if I put it in this analogy, if I get some real comments on this, because most of them won't be able to answer this. If I pretend to be a doctor and I show surgery on my channel, I'm going to prison. If I pretend to be a pilot and I go through showing you how to fly a plane to the best of my ability, I'm not meaning to hurt anybody, but I'm not a pilot, that also would leave me in hot water if what I'm showing you is incorrect. But it's okay. We have content creators. This guy's video is literally a month old, which means this technology is out there, this knowledge is out there about what I'm talking about, and yet he posts general information about CNC robotics that can potentially hurt someone. And using the incorrect cables does hurt someone, because if they have any robot that is once again spewing EMI all over the place, it's going to be left unstable or have the potential thereof. So the question now is this: if we know this, and we know that in other genres and other career facets, if people pretend to know something that they actually don't and it accidentally hurts someone, regardless if it's accidental or if it's intentional, they would be held accountable. Why would we not hold them accountable for once again posting videos that are done with a complete disregard for the safety of who they're working with, meaning their audience, and also if what they're providing can actually be detrimental to their investment, which is their robot. And I know there's not going to be comments addressing this, because what most of the comments come back that I've seen when I say something like this are, well, you know, the end user should be doing their own research. That's absolutely true. I totally agree with that. But hear me out on this. When we see more and more of these videos hit social media, and these people doing the same redundant thing because what they do is don't think for themselves, they practice what other people do. If we don't eliminate that, it takes precedence over these people doing their own research, because when they do their own research, they see more and more videos like this, and they see a consistency factor, and that consistency factor once again sways them from doing even more research, which actually lands them on the correct potential information. Now, when you think about what I just said, and I really want you to digest it, if you, once again, are those people leaving these type of comments, watch this portion of the video again. I'm telling you with a fact, you would have a totally different feeling about all of my videos if any of this information that these content creators have provided that I do the videos on actually affected you negatively. I want you to think about that. And think about the potential audience members that these content creators have that look at this and say, oh, he just used a general power cable, it's all good. And then he has a problem, once again, and I've said this in many videos, where does that person go? Does he go back to the content creator and say, hey, you made a video on this, and now I'm having a problem with my machine? Guess what? The content creator has no liability. And is that right? I think it's right if the content creator is vetted to actually show that what they're doing is best practice, if that's the realm they want to go down. But when we have people pretending to be pilots and doctors, we have a problem, guys. All right, we got to watch this carefully. All right, so we have the content creator who modified an IEC power cord once again to power on his VFD from the wall outlet. The issue is this. We can see here he's using the bare copper conductors of this power cable to once again connect to the terminals of the VFD. Now guys, again, this is the VFD coming from the wall outlet. So this is not technically an active cable, meaning it's not going to be in motion. That being said, the choice is yours on if you would want to attach it this way, but I'm going to give you my feedback on what I think about doing any connection on a VFD where we're just doing bare copper conductor insertions into the terminal block. And my feeling is simple. All connections in best practice should use a soldered on ring connector where the screw goes right through the hole of the ring connector and cannot break free. That is the safest method of actually terminating a VFD. I'll put an insert here of a video where I've covered this and I've shown how it looks when it's installed. And again, this assures that we do not have any accidents happening with fork connectors or crimp connectors. A lot of guys like crimping. And again, the thing to keep in mind, crimp connectors have their place if you're okay with a connection that may or may not be correct. I have some guys that'll argue the point and say, I've done crimp connectors for years, I've never had a problem. Well, that's fantastic. The issue is this. This is a precision robot. I don't care if you're using it for hobby use. I don't care if you want to claim that, the tolerances don't need to be that tight. If you wanted to do things by hand, you wouldn't be using a robot. Fact. Okay? So let's be real. Let's do things with a sense of precision that is applicable to what we're working with. And that being said, we should be looking at, number one, what's safe. That's the most important thing. These content creators never even cover that because I really truly believe they don't understand it. They don't even mention it in their videos. We haven't heard anything from this guy about safety. The thing you need to keep in mind is that if this cable even though it's coming from the wall outlet, gets pulled on in any way, shape, or form, just maybe him servicing the unit, you are going to have tension on that. And being these are just bare copper leads, it's very easy to fracture them or once again pull the cable out. If that happens when the unit is on, it could be catastrophic. That's why I recommend soldered on ring connectors. Now, of course, on the VFD side that's actually going to the spindle's power cable, that is mandatory. And I'll say that again, mandatory to use soldered on ring connectors for safety, because that cable will most likely be active inside a cable chain where the cable chain runs back and forth and moves with the axis, the X and Y and the Z. And as that cable moves and it's active, any tension on that cable could inadvertently, once again, fracture a lead if it was inserted like this with the bare copper conductor, or if we're using a fork connector, it could slide out. I've seen weird things happen. I've heard of weird things happening. Again, I've been in this industry for well over a decade now, and I can tell you things will happen. There are principles for safety that should not be overlooked. And another critical area that I always point out, you never hear these content creators ever discuss, is your insurance. And why I say your insurance, God forbid you encounter a fire or arcing, these content creators aren't going to back you up. What are you going to do? Tell them that, oh, I watched so-and-so on YouTube and this is what he said to do, so I did it? Come on, guys. You got to be real. I mean, the bottom line is this. I would always go with the safest manner possible. And the reason I'm bringing that up is not to give you a headache. It's to make you understand the gravity of what you're working with. You don't want to be the guy that looks back and says, I should have did it this way. I wouldn't have had any of these problems, and so-and-so wouldn't have got hurt, or God forbid, my house wouldn't have burned down. You don't know what you're playing with when you disrespect electricity. And I'm telling you that. I've seen it many, many times. Guys get very comfortable. They start working with tools around it, and they kind of disassociate themselves with danger because it's all around us. I mean, you've got to have respect. And again, as a content creator, I find that this responsibility should be carried over when you're working with these type of high voltage electronics. And again, they're precision electronics. These are not toys. These are not, once again, there's not a hobby-based VFD. You're not going to find a guy saying, oh, it's just a hobby VFD. No, the manufacturers build them all the same. You want to use it for your widget? That's fine. You want to use it to make money? That's fine. If you don't want to make money with your equipment, I think that's kind of silly, but that's my own opinion. Either way, what we're seeing here, you be the judge. Once again, this is the VFD power cable coming in off of the wall outlet going to the VFD. So if you're okay using just the bare copper conductor because you feel that this cable is not active, meaning it's not in motion, that's fine. But remember, accidents do happen. I myself, I just use soldered ring connectors all the way across, and then I never have to worry.
Hello everyone, and salutations. Today I'm going to explain an engineering concept using a whiteboard. I've decided to use the 48 volt.
All right, now this would have made a fantastic topic for a video. This content creator could have done a video on this topic. I think he would have hit it out of the park. It's super content. He probably knows a lot about it, and it would have eliminated a lot of guesswork for guys that want to play with voltage dividers. Once again, he's working with an old spindle. It uses linear voltage, 0 to 48 volts, 0 being 0 RPM on the spindle, 48 volts being 100% RPM on the spindle in his current configuration stock. And then he's going to a new Spindle VFD combination in which the VFD uses a PWM voltage, which is 0 to 10 volts, 0 representing 0 RPM on the spindle, 10 volts representing 100% RPM on the spindle. And again, he could cover this topic in great detail, and it would have been super beneficial to his audience, and I feel he probably would have literally helped a lot of people, and it would have got people set up if they wanted to go that route. The issue is, and just like content creators perform, because many of them do this, they have one area of the video or multiple areas that they just have small segments on, they actually really know about, and then they put in sections that are just content filler that they don't understand, where you're using the incorrect cables, in which case those incorrect cables can hurt other end users with their robots if they mimic what you're doing, because then they will have an unstable robot due to the electromagnetic interference that's being spewed all over their shop. These are fact. And what's really interesting is, excuse me, is that the more we see videos like this, and the more I do content on this, I always get a slight backlash. I'll get guys saying, oh, you're condescending, or oh, you feel, you're better, you're bashing someone else. No, it's not that. What it really is that if I'm a liar and I'm portraying that I know something I don't and it can hurt someone, if I was saying I was, for say, a police officer, and I kept telling people that, and I went outside and I got caught falsifying that I was a police officer, well, then I'd go to jail. That's the accountability factor of that falsification. So when we see stuff like this, the algorithm is not there yet. I've said this in previous videos. It's getting there. It's going to start vetting what's being posted, and in which case it could alert this content creator, hey, you know what? Maybe just go with this segment. You're good with this. Don't go with this, because what we're seeing here is not jiving. That makes more sense. I mean, there's guys that claim to be Navy SEALs all the time, and there's stolen valor for that. What I'm saying is the people that care about my videos are the ones that typically are burned. They're the ones that have already seen, hey, I bought from this vendor. I can't tell you how many retrofits I've done where they claim, hey, I bought from this vendor and this guy's system sucks. Everything you've said in your videos is fact, it's dead on, and that's it. That's why I'm successful, guys. If I was just a bag of BS, why would I sell anything? Wouldn't make any sense logically at all. I'm telling you what's fact.
All VFDs have some level of programmability. I'm going to talk about this particular one, give you all the rundown. I'm going to save you a boatload of time with this cheat sheet. So,
all right, guys, we're in the portion of the video where the content creator is now providing you VFD settings for the particular setup that he has. He claims that he's saving you time with these settings, but then he also puts a disclosure on the screen that says VFD factoring settings may not match the motor. Be sure to check or you will get unexpected results. Well, let's be real. The unexpected results you may get is damage to your spindle or your VFD. These are very critical settings, and I'm sure he's aware of that. I also feel that all of you out there need to ask yourself a question when watching a content creator present settings on a VFD or any other component in your system. And that is that if earlier on in the video you notice that something is done incorrectly, like his choice of power cables for the VFD and the spindle itself, he just chose to use regular cables and he just really documented the wiring diagram for connecting these cables. Now, in doing so, he feels he covered everything because the spindle powered on. What he doesn't realize is if you don't use the proper cables, meaning double shielded cables to mitigate EMI, you will have the potential of having an unstable production robot because you're spewing EMI all over the place, and the only devices that do that the most are your spindle and VFD. So, if you know that portion of the video is incorrect, why would you take what he's putting here and put it in your system, knowing that if that was wrong, the potential for these settings may be wrong, along with the disclosure he puts on the screen, which basically, once again, alleviates him of any actual regard for any problems you have, because you're not going to go back to him and there's not an accountability factor. It's going to be, hey, you know what? You put the wrong settings in. My settings don't match your settings. Shouldn't have used them. I cannot tell you how many past potential clients I've had contact me about VFD settings on the Wanyang. It's the most popular VFD. It comes from overseas. It's a very high quality unit if used appropriately. And what's really funny is many vendors just do not discuss how to set these units up, yet they come with user's manuals. As a matter of fact, the user's manual is right there in front of them. I'm going to put on the screen here the generic settings based on Wanyang. It's an actual printout, and I'm doing this as a vendor, and I'm doing it as a courtesy. You didn't purchase anything from me. I'm dispersing this. You can check it out for yourself. Now, he's got an air-cooled spindle motor. These settings, once again, are specific to certain motors. The motor he has there is matched in the kit he purchased. Therefore, all of those settings that he's putting on his yellow pad here, along with the disclosure he has here, is only applicable to his particular motor. And that means in that particular kit. In any event that they decide to change that motor, even if it looks like the square air-cooled spindle, it may have different settings. And if you put an incorrect setting in, you can easily destroy the unit. So the best thing to do not listen to content creators trying to give you settings, because again, they have no accountability if something goes wrong. Your vendor does. That's where the vendor who's selling you these components should understand them and support them properly, so that in the event you have a question, you will get the right answer to make sure your unit is working as designed.
The VFD is showing that it's running in the forward direction. However, it's actually running in reverse. And so since it's a three-phase system, you can just swap 2 of the 3 wires, excluding ground. So in this case, it's red, white, and black. You could swap red and white or white and black.
All right, so this is a great illustration for those of you who send me questions regarding wiring additional componentry within the terminal junction area of the VFD. And when I say junction area, I'm talking about the power distribution terminal block that's coming from the wall outlet to the VFD to provide it power. And I'm also talking about that same terminal block where it's providing the spindle power. Now, what we see here is this content creator installed his voltage divider components within this area. You can see how busy this is. I'm going to state this for safety more than anything else, that any of these type of components that you're adding additionally, other than a ground bus, if it's installed properly, will once again make everything neater in wiring. This makes things busier. And in best practice, these should be installed on the outside of the VFD. We have a cable pass-through area here, and actually you can see the boot in this image. I'll put an arrow on it. And again, that would be the optimal way to install any additional components, whether it be with screws on the bottom, whichever way you have to do it. And the main reason this is, guys, logically, is we don't want to have, God forbid, any metal-to-metal contact with that terminal bus. Or, once again, we could have a catastrophic event. We could have fires. We could have electrocution. We don't want that. So, in best practice, watch very carefully when you see anyone, content creators or anyone on Instagram or whoever it may be, put components within the VFD's junction area. It should be as clean and tidy as possible, nothing floating, and everything should be connected and secured properly. This is best practice. Once again, I want to thank you all for your support. I'm getting a lot of comments, and you guys are really interested in what you're seeing here. And again, I cannot emphasize enough, I'm certainly not trying to be condescending. These content creators, they are putting their time and effort into videos. My only suggestion would be put the time and effort into the portion of the video, wherever there is one, that is with correct information. You're obviously not trying to lead someone down the wrong path, but that means you're going to have to do more research to make sure that the information you're providing will not potentially hurt another end user inadvertently. You certainly don't want to hurt your audience, and that's all we're asking you to do. Thank you for your support. Take care.